Hello, everyone. Welcome to Security Pulse. Welcome to our YouTube platform where we share insights and where we engage with professionals to share the emerging technology content as well as cybersecurity insights. Thank you very much for all you who have joined in. Today we have a very special guest with us, Mr. David Soldani. Soldani has been a mentor for me. He's been very prominent figure. He's a senior member of IEEE. He has received an MSc degree in engineering from the University of Florence, Italy, a DSc degree in technology from Helsinki University of Technology, Finland. Throughout his career, he has held prestigious academic positions, including a visiting professor with the University of Surrey, an industry professor with the University of Technology, Sydney, UTS. He's also an adjunct professor with the University of New South Wales. In his professional roles, he has served in significant leadership positions from Chief Information and Security Officer to SVP in Innovation in Advanced Research with Rakuten. And also previously, he has held positions of Chief Technology and Cybersecurity Officer with Asia Pacific region, Huawei. He's also a head of 5G technology, being end-to-end global with Nokia, head of Central Research Institute. He's also been involved in different, webinars with respect to with respect to 6G and eBPF technology. So it's been an honor for me to have Mr. David with me. Hello, Mr. David. Welcome to the show.
Hi, thank you for having me, and hello to everybody.
Hey guys. So this webinar is all about eBPF. eBPF has been there for a while now, but it's been used more so diligently in the telecom space. So we'll talk about eBPF really from the starting point that hey, what is eBPF? eBPF is how we can use it, what are the different use cases, where it how we can apply these use cases into different environments, especially the telecom domain. And we'll ask Mr. David that based on his experience about what are some of the challenges when it comes to design and practical implementation of eBPF. And we'll also be having some Q and A's in the end. We'll be asking questions with Mr. David about on different pressing topics regarding eBPF, and we'll be also asking questions from our audience. So just stay tuned and just enjoy this session. I'll now ask Mr. David to share the screen and just take it from here.
Just pop up here. Yes, so thank you, Taha, for having me. Put together a number of slides. So the slides are just used for explaining a bit better what I would like to share with you all. Thank you for the comprehensive introduction and as well. Can you see well my slides now? My screen? All good, yeah. So as you said, so I've been acting now in the information and communication technology field for about 25 years, and have contributed both as an industry player and as an academic. I'm still active within the University of New South Wales as a joint professor, and I'm currently employed by Rakuten. And Rakuten, I had two roles. I initially served Symphony as Chief Information Security Officer, and then I moved to the Rakuten Mobile, and heading the next generation advanced research division. So what you will see today is one of the topics in focus within my organization. My expertise was initially on future wireless networks, appliance of security, artificial intelligence. In the last 3 to 4 years, my main focus has been placed on cloud native architectures and fundamental enabling technologies, thinking of observability, security, and networking. And today, we'll be looking to what I think is the most advanced and relevant technology for instrument Linux kernel, and therefore on a cloud native platform achieve advanced observability, security, and networking. Okay, that's basically about me. This presentation is very comprehensive because I have a very crystal clear vision of how what we should have on 6G. So let's go through quickly and position eBPF on a much broader scope, because people they think only about, oh, I have my laptop here, or I have my server. Let's see. No, I mean eBPF is gonna be and will be all over the places, or all over the machines hosting the modern Linux kernel, but also Microsoft Windows coming, and later I think all operating system will support eBPF, and as this virtual machine is going to be standardized within the standardized and made available through the IETF broadly. So today we have this kind of networks where, for example, if you think of Rakuten Mobile, we have virtualized the entire infrastructure from the radio access down to the core network. And now if you look at how the system works, we have a cloud infrastructure. So you think of your servers or dedicated hardware, where you will install your operating system, on top of which you need a container orchestration platform, and then you onboard your virtual network functions, and that's a quite hard work, because the VNF, we did not design VNF to run on within containers, but they were specifically thought to be on virtual machines for various reasons, also because the containerization was not available as a fundamental enabling technology at the time. Then we introduced this nephew, which is a Kubernetes-based telco domain automation, to alleviate the pain, automate the pain, to bring on board the function. What I think of 6G, and I hope we will ultimately achieve this goal, we will make it cloud native by design, which means particularly that that particular functions, virtual network function, which I call cloud native functions, will be suitable to be on my platform, not the vice versa. Let me repeat this. Cloud native means that what you do is suitable to work on my clouds, not the vice versa. So I don't want to change my infrastructure or buy specific vendor hardware to have your workloads on my systems, vice versa. That means cloud native. Hopefully we will achieve this goal and meet the requirements of the CNCF. And eBPF will be a fundamental enabling technologies that will allow us to achieve advanced observability, networking, and security tooling across the entire infrastructure. Now, where do we find also eBPF? Because if you think of the business processes where I used to work for the vendors, we had a completely cumbersome and inefficient way of developing products. So I remember my team had to do research, and then I had to pass the results to the feasibility study, system feature specifications, implementation specifications, and then we had the software development, testing, piloting, impossible. Now today we just expect to have workloads, and the workloads are coming to a network with a continuous development and integration, seamlessly done on our infrastructure by simple commands on the Kubernetes platform. So we need to enable this DevOps, and then DevOps needs to come with the security. So there are various aspects of security here. At least we gave 9 points across the process. eBPF finds especially place on the security, runtime security, will be number 7 here. Now we understand what I mean in a second. So now jumping into the eBPF, so I tried, so I'm not sure how familiar the audience is. So I prepared also a couple of slides to introduce the topic and share a bit more on the use cases. So eBPF stands for extended backend packet filter. BPF originally was in the kernel as introduced as a filter. We are back into 2000, so about 10 years ago and earlier, but now eBPF or BPF, we have stopped playing with disclosing the abbreviation, just say BPF or eBPF. It's basically a virtual machine available in the Linux kernel. This virtual machine has a lengthy instruction set that depends on the kernel version. The more recent the kernel version is, the more instructions or helpers functions you have available. And nowadays we achieve millions of line of codes on eBPF that those are possible. And so that virtual machines allow us to instrument the Linux kernel, program the Linux kernel, and so we achieve we do have the ability then to change the source code. So without changing, say, recompiling the source code, we can modify the Linux kernel, its behavior without harming its stability. And each eBPF program, it is portable, it is atomically updatable, and when you run the program, you inject the program, it executes in real time without any need to reboot the node, the VM on which the operating system is running. And I will show you that is also verified before it is attached to the specific hooks, thus making this solution extremely secure, reliable, without any harm to the stability of the kernel. We do have 4 main category of use cases: security, which I will go a little bit deeper today, observability, and then networking, traceability of the various applications, functions, and primitive that across the Linux kernel, and data profiling. As I said, it runs specifically on Linux for more than 10 years now, and it's now also available on Microsoft Windows. Later, I think all operating systems will support this virtual machine. Now, how does it work? Well, what do I need for, say, injecting my programs and programs instrument Linux kernel? I do need an SDK, and there are many packages available, starting from the BPF compiler completions, which is a sort of interpreter, very easy to start, and programming with that comes along with Brenda and Greg. I met Brenda here, he is in Sydney, and he is basically the one who contributed the most. I particularly think of tracing, traceability, monitoring. So BCC is definitely where we could start if you are a learner, but it's not truly, at least my team is not using this in production. In production, we use Go and eBPF because the Isovalent, our friends from Isovalent, they made available massive libraries, or you can use C and libraries of the Linux kernel. I will show you an example with this, or if you are an expert on Rust, you can use the framework Aya and Rust to write your eBPF programs. So yeah, that's basically the overall frameworks. And now let's go a bit deeper. Why this technology now is coming, and it is so relevant and will dominate, I think, all platform hosting the modern operating systems, from smartphones, satellites, base stations, core network elements, routers. We also instrument routers, for example, with my team, and it is amazing in terms of programmability. I'll show you. I also can do it. Program on real time and safe. It is extremely stable, and overhead is minimal, so you can't perceive this. Because it's such a small program, you can't perceive the application impact on the CPU or memory. or other resources on your platform, and it is particularly suitable for the telco network. Because telco, that we do have massive workloads hosting those cloud native functions, so you don't have much room of leaving as an overhead to external applications. And then when you look at the performance, is outperforming any kind of solutions and evolutions you're having on the Linux kernel itself. So, for example, you do have ability to trace anything or at application, and across Linux kernel, the performance are exceeding traditional IPVS or IP tables of a factor from 2 to 4. And then you have an extremely easy way to look up the rule on the tables when you think of balancing the traffic entering into your cluster. So we shift from ON, so going with n number of the rules on the table, to 1. So it's a constant. Okay, and then I will show you today how we use that for real-time detection and response, because I can execute my policy in the Linux kernel. So Brendan says that Brendan, but also Thomas Graf and Leeds and anyone who has really contributed to this fundamental enabling technology, they say that eBPF is to Linux kernel, and they have added now MS Windows what JavaScript is to the web browser. So it really helps us to modify and deploy the changes we want on our machine. Maybe a couple of slides how it works, and I will also give an example. Think you are on your server now. The server, you may split into 2 domains. One we denote as user space, where we place our applications or core network or workloads in general, of network function microservices, and then we have the kernel space. So something that it is between you and the resources. You means your application, the resources. Now, how does it work? You will write your eBPF program using either C or Rust. Is up to you what you're familiar with, but it has to be a low-level language. Then you have to compile it. So compilation, you may use this RLM VM project or the CLAN compiler, because you need to compile on bytecode. So the bytecode, it is basically a compilation of the file which runs everywhere. So we see a core, so that the kind of bytecode is independent of the underlying hardware. So it could be, say, oh, what should I do if it is an ARM or if it is a x86 processor? Don't worry. So you just compile it. You compile, you achieve the bytecode, and then comes the issue of, okay, what kind of hardware I have? But that's going to be taken, that's going to be resolved by the just-in-time compiler of the Linux kernel. So what you do here, then, you have your eBPF program now prepared. It includes also some overhead and the maps. Then you use BPF system calls. So that's part of the helper functions that come along with the instruction set of the BPF VM machine available in the Linux kernel. You have 2 system calls. So the first system call injects the program into the Linux kernel through a BPF program load system call, and then at the same time we create the maps. So maps are tables, or they could be hash table arrays, RRU, ring buffer, whatever. So anything that allow us to provide the state to the program we create, because the program itself are stateless, but we need to have a way to create a memory inside the kernel, and then a way for exchange information between the eBPF program in the kernel and pass information to the user space. So you do have a constant dialogue between the application, I call it agent. For example, we do have our own Sauron agent that does it, and the kernel, and vice versa. So I inject this program into the kernel. and then the program is immediately verified, and then it's compiled here. When it is compiled here, the compilation goes into native instructions that relates to that specific machine you're having on your hardware. Okay, fine. Then point number 5, what we do is using another command, we attach that particular program to specific hooks into the kernel to perform and being executed when that event is triggered. Okay, and I have some examples later in this document. So that's pretty much how it works in a high level. And now when you look at the hooks, so where should I, and eBPF programs, what kind of categories of eBPF program I can create, means based on the use case I want, and then where am I able to attach them, which are linked, by the way, to the use case. I made this table through a summary from the book of Litz Wrights, my friend Litz. She's one of the most knowledgeable person I have met and discussed with. So my suggestion is just you go from this book, you read this book. It's a very good starting point. And yeah, so we had two category of programs you can create. We call tracing, or for performance purposes, programs, or networking. If you do want to trace what's happening into the machine and the applications, then you will use these hooks. Those are examples of hooks and program types. So you have probes, K-probes. So just give you an example, because we could spend one day on this. So K-probes are pretty much functions of the kernel I can use to attach my programs all over the places in the kernel, which means if I don't have ability to find an helper function here that allows me, or a macro that allows me to instrument the kernel, I can think of using a K-probe, and then the K-probe will help me to play the role as a hook, to have that program, my program running, for example, when a particular system call is triggered by the application. Okay, then there are trace points, which are a list of location, marked location in the kernel you can use to attach your program. And then there are U-probes and U-red probes, depending on where you want to tap on the enter, exit point, or the user space function. So that means you also have ability to instrument your workloads, not only say determine the behavior of the Linux kernel. Okay, then the networking, you can instrument sockets, the traffic control, which has model of the Linux kernel that play a role into the traffic when it enter the kernel, leaves the Linux kernel. Or you can play with express data path, which is also available on the network interface card. So you don't need to play with the generic XDP into the kernel, but you can immediately attach your programs on the network interface card and take actions before even the kernel is involved. And then C groups, they introduce plenty of flexibility for other purposes. So that slide's already taken from that book, shows you the user space, the kernel space. So you have your processes, or for example, workloads related to the cloud native functions. And here you may see your eBPF program that are to be attached using U-probes or and to the inside containers, and then ability for you to instrument everywhere everywhere, or any function, say in the kernel, from system calls down to sockets, and then network interface cards, and then also when the traffic leaves and enter the Linux kernel, or you access the external devices like drivers. Yeah, maybe yeah. Now I will jump to the conclusion now, because I think we can have also a more interactive conversation. I want to spend, just a bit more time since this is about security, on the kernel runtime security instrumentation. So going back to this tables, I would like to explain a bit more what the Linux security models is, and now we can use it to instrument the Linux kernel and achieve advanced security tooling. So that's I'm here now. Let's consider this eBPF program type or hook. Okay. There is a video here. We made available on the slides. So you can look at the video. So I've just made a summary of this video, which is rather comprehensive on the utilization of the Linux security model hooks. And once you have ability to attach your programs to these hooks, basically you have capability to achieve the and influence or instruments a number of operations in the kernel. So for example, you have ability to see what's happening in the kernel when there is an attempt to open, create, move, or remove files. That's very, very, very important. Or if somebody, for example, is mounting or unmounting files, if, for example, you think of the persistent values in Kubernetes, or you can see whether somebody is attempting to allocating and freeing tasks, because you can really monitor the inter-process operations by tapping into the specific LSM hooks, or also play at the socket level. And the messaging, so the system calls related to sending and receiving messages. So basically you have a package, a framework here you can use and to attach your eBPF programs, or use these macros and helpers to achieve this extended way of instrumenting the Linux kernel without, say, spending too much time into learning all the trace points or how to attach K-probes to different system calls. I find this extremely useful. There are some drawbacks here, because one thing is the what's coming, and one thing is the reality. So you need to look at your operating system. So the operating system you're having in production, and you will find that perhaps version 5.7 is not there. So that you may have it maybe in 1, 2, 3, 5 years from now. So that means when you create your eBPF program, you need to look at your kernel versions, and that will provide you with a set of instructions you can use with your eBPF. So if the version is 5.7 or higher, then you may use this set of hooks and instrument the kernel broadly as shown on this slide. Okay, here you have details how to do that. I will skip that because I have another example. This is the example I want to give you, and then perhaps I show you what we do with my team, and then I will conclude my presentation. So let us, I prepared a demo, which, by the way, it is a demo from Leeds Rice. I went through this tutorial, and I did it myself. There is no way for you to lead an organization if you yourself you don't understand this. So I'm the first one who always tends to explore new things, test them, verify them, and then when I think it is technically feasible and business viable, I would then involve my team to go deeper and realize what I think is my vision to move forward. So, but that's an example I did through following Leeds tutorial. So just playing with that, and let's see what it is. So you need two things. You need to have something that allows you to write the eBPF program. Then you need to have something that creates a skeleton for implementing the whole process I presented you earlier. So in this case, we use C, just C, and we create a makefile, an eBPF program, and then all operations are done through the BPF tool. Okay, BPF tool is available in the kernel so you can use it. So that's how we do it. Or you can have a complete skeleton using Go, okay, or even C++, or with the BCC, you're using Python. Now, in this case, we use C and the eBPF libraries, so that through C and making use of these libraries, we can create our eBPF program and define the attachment points. So that's the first step. When you create your BPF program, you need to also specify the attachment points, which means you need to find the section, the macro, that after you compile it, will instruct the Linux kernel where that program will be attached. That's the first step. Then, now you know what the program is, you know where to attach it, because that is in the macro you are having at the beginning, like written in here. Then you need to have another instrument that load that program into the Linux kernel and then enable the execution. And that is done here using the BPF tool. Okay, that will perform the loading of our bytecode and then will then consequently attach it to the event, which is specified in the macro at the beginning. So let's go through the software. This is a simple BPF program, which means anytime it is triggered, it will print on screen, actually it will trace hello world, and will increase a counter. Okay, that's very simple program. And I'm going to attach it on the express data path, or use the express data path as a hook here, which means once a packet arrives at my network interface, then this program will be also triggered, because that's where the express data path software takes place. Okay, that's the program. And I'm writing the program, and I'm using this macro here. The macro itself, it describes as the program type and attachment point, which in this case is the express data path. So we are going to attach our program here. Okay, here. Okay. Now, once this is done, I need to compile it. So for compiling it, I need to use this, either the project LLM, or I can use the client compiler. So in this case, I'm using the client compiler, and I compile it so I can generate the bytecode. Once I have my bytecode here, so this is the two things. Writing in C, my BPF program, using that specific macro, which means library, in relation to the hook I'm using. And then I have a maker file, because I have to compile it and produce a bytecode, which is basically denoted here as hello. Okay. Once this is created, now I have the task of loading that and attach it into the kernel. How to do that? I use the BPF tool, and I use simple command, BPF program load, and this is loaded. And then I could also see, using the BPF tool, that the program is loaded into the kernel. Yeah, and the command, I can see, okay, good. Okay, my program is in the kernel. And the idea of the program is 131. Then I need to associate the program with the event. So I need to attach this program to the XDP. And here I have another command mentioning XDP, the program itself. And then I can see it with another command that shows the list of network interfaces that my program it is attached to the loopback interface here, which I have decided as a location where the program should be. And then I want to test the program itself. I open another shell, and I just ping my local interface, which is basically 127.0.0.1. And anytime I'm pinging it, the program is triggered. And you can see here that by reading again the trace logs using the BPF tool, I can see that the program is working. It prints anytime I'm typing. I'm pinging the localhost hello, and the counter is incremented. Okay, so that's basically the basics. Taha, how much time am I allowed to use still?
We can use we can cover this eBPF for Kubernetes as well. I would love to go on and on. This is very interesting. So let's do
Okay,
one more
maybe
topic.
allow me 10 more minutes. I don't have time
Yeah.
limit today, so unless you, but
You can do this eBPF for Kubernetes, and then we can go to the Q&A.
Okay, so very quickly, here I'm showing the benefit of eBPF in terms of networking. For example, this is how Cilium achieves reduces the overhead and increases the performance. When you look into the details, you have a rather convoluted stack because when we move from node networking and you bring that networking into the container, you are introducing you see here 100% overhead, right? So there is a possibility to simplify the Linux IP tables using eBPF and improve the performance, as I said. I mean, you can bring the capabilities you're having for service mesh currently on the sidecars down to the Linux kernel and use eBPF and reduce the number of sidecars from n, where n is the number of pods you're having in your clusters, down maybe to one service mesh service mesh proxy if it is really needed. You can bring also security down to the eBPF, getting the best out of the, say, service mesh software that, for example, introduce a sidecar or any pod which is extremely heavy. You can use this kind of functionality, bring them down into the eBPF and making the system extremely lighter. Consider that there will be only one identity and certificate manager compared to here having all the processes across all the sidecars. Now, looking at the security, for instance, this is taken from Leeds Rise, and this is what we are currently implementing using Sauron in my team. Why eBPF is so powerful compared to traditional asynchronous methods. So think of having now a malicious pod, which is the blue one here, that has ability and the privileges to harm the Linux kernel, take action, say, on your machine. Now, if you use a traditional application, the application, how it will work is that it will play asynchronously, which means that once the kernel probe detects that there is an intruder, it has to report this to the application, and the application, so it means go up to the application, and the application needs to make its own decisions, and then they push down an enforcement like the signal to kill the particular pod. So you do have time here between, say, the action and reaction, and that basically allows plenty of time to the malicious application to harm and even crash your machine. So if the, say, policy in terms of detection and actions is already in the kernel, that kind of ability to harm the kernel is basically removed because the action is immediate. Okay. So that's one example. Then there are many use cases, and some of them we have also implemented in our organization, my team. For example, eBPF is used for avoiding catching crypto jackers, which means here as if you have only your controls inside pods using sidecars, for example, you can't detect actions taken by a malicious pod in your cluster, whereas eBPF does this ability here because we can tap all over the places. Then observation-based policies here means that we could have policies where we are whitelisting the legitimate application's behavior, and then using eBPF, we can restrict the PID to certain files or block processes or even any sort of capability you may have in the pod for, say, an attacker and escalate and get the privileges to harm the kernel. We can block it like it is illustrated in this figure, because with eBPF we can detect this capability and then kill the pod immediately. We can prevent, you see, by instrumenting the express data path, DDoS attacks, no problems with that. We can detect the packets, abnormal traffic, and then We can drop the packets immediately, even before, as I've shown you, before it reach the Linux kernel, if the instrumentation is done on the network interface card. And then the civil sandboxes, it means when you have a malicious software or malicious sandbox, say in your cluster, we can detect abnormal activities and return information by changing it. On the other hand, perhaps this is also interesting that eBPF, it could be also a very powerful tool for malicious behavior. So these are example of malicious use cases where eBPF kernel rootkits are used to tamper or harm or as an attack vector to your machine. Now here we could also spend a couple of hours into this, but as eBPF may protect you, of course, can be also adversely used to fake everything in the kernel, even like you can't see what's ongoing in the kernel. You can change the privileges to root to a particular users where the administrator can't see that this guy, he or she is a root, or you can manipulate the packet so that you can exfiltrate the information. So, okay, how to resolve this? This is a big problem. You would need to still use eBPF, or in certain cases, you need to recompile the Linux kernel that eBPF is disabled. Okay, that's all. In high level, then I would have more stuff on what my team has done. So we have our own platform, and we are using now extensively. We presented the Mobile World Congress 4 fundamental use cases. So we have ability to extract information from Linux kernel and sort of application. We generate synthetic packets, so we can measure performance end-to-end, hop by hop, on any element supporting Linux kernel. We provide security measures. I gave you some example of it. We can measure energy consumption at the pod or any application level, microservices, cloud native function. That is amazing. So that these are example of use cases. And we also made available a thesis. So you asked me what kind of software and other application use. We have implemented Tetragon, enhanced it through a Promptel, Loki, LogQL, Grafana, Prometheus. So now we have ability, for example, to see not only through logs, but in real time on screen what's happening in your machine if some files have been tampered, or the change mode of files has been made, say, improperly, so that people they can gain access to information that that you are not willing to disclose. So that's pretty much an introduction. I hope it was useful to see where we are with this machine.
Very useful, Mr. David, and thank you very much. It was, I couldn't realize that we end up, you end up presenting, 40 minutes, and I would like to go this on and on, but like sadly we have like only enough time, So as you were going through the slides, I have few questions. I was just writing some notes before I take the audience. I would like to ask you a few questions. So yeah, so like clearly the potential is very much, and we have seen there are a lot of project which is also been going, and like research as led by you and your team. There's a lot of work which has been going on. So where do you think, is there any like working group inside the telecom standards organization which is dedicatedly working towards this exploring eBPF potential, and to make sure that whatever kernel version what we are using is in the cloud infrastructure is supporting those applications and those use cases which has been coming up with eBPF?
So these are there are many initiatives ongoing. So most important initiatives, I think, are within the CNCF, so the Cloud Native Computing Foundation, where hundred of projects are made available, open source software, and that's one thing, right? There you're having, say, the solutions to specific problems. Then when it comes to the standardization and massive adoption. There is now an important initiative ongoing within the IETF by Google, and then Facebook, or Meta, Cisco, and then I think, if I don't remember, if I remember correctly, Amazon, and perhaps also IBM is involved. So the idea there is to have a common language, a common instruction set that would then run on different type of operating system, being Microsoft already, say, part of the group as well. So that's another important initiative. However, I have been invited to give a few talks. There was within the Oran Alliance and GRG group, Oran Alliance, so thinking of Open RAN initiative. Then I spoke to the in US at the Next Generation Alliance. So all these initiatives were looking into 6G. And eBPF was meant to be one of the fundamental enabling technologies. And yes, I hope that the telco community, which they come from the workloads perspective, so they will need to go now a bit deeper into the vertical stack, and adopt and adapt eBPF to having that on the spec for the current evolving system and next generation system. I hope that that will happen. It is part on
True.
also our contribution to influence
True.
them, have it to make
True.
things cloud native, not vice versa. Like
Yeah,
said,
yeah, yeah, yeah.
yeah.
True. And one follow-up question, what I am thinking is, or I would say a concern that is happening, because as you know that eBPF, we normally when we talk about cloud native and mesh networking, there is a considerable number of shortage in the resources, both in the operator as well as in the vendor, and that is why, like, one of the reasons why we don't see it implemented so like often, and because it comes with the operational expenses, some troubleshooting requirement as well, and we need to have some enhance of the skill set of the resources who are actually leading these initiatives. So with this in mind, do you think like gen ai would be useful in trying to bridge the gap of skill set in trying to build the design and do the operations using eBPF?
Yeah. So, like language models, or large language models in general, or enhanced language models using RAG, or agentic workflows and so forth. Yeah, definitely will help, but they're not trained yet. So we haven't found it. Actually, if you are aware of having a language model now being trained properly to write BPF programs, please reach out because we are very interested. But it will be possible. You need to train
Yeah,
the.
yeah,
Yeah,
yeah.
definitely yes. The answer to your question would be absolutely yes. So we could think of not only, no, but you need to train it, right? Not only helping into writing BPF programs, we could think of automating the project. Like it's rather cumbersome. There are interesting SDKs now, but perhaps we could achieve. Absolutely yes. The answer is yes. I hope so. I'm open to learn into this direction. We haven't found much.
Yeah,
We're still
yeah, yeah.
using Go, and
Yeah,
but yeah.
just to give you an idea to where we are standing at, as the industry. So I was also at the IEEE Oran conference just like recently, and there was a presentation given by one of the gentlemen about Linux kernel hardening, and and how it's been helping the Oran community in general. And when I brought up this point of having an eBPF use case and have a dedicated kernel for Oran, for to testing, so we don't have a clear answer yet to who is doing that work, where we can find more information on that. So there's clearly a gap in the industry that we need to fill in, and with your leadership, I think we'll be well positioned to do it, and the kind of research work that you and like Rakuten team is doing, so it's incredible, so if we have to find more use cases and to explore more on this and try to maybe use some of this in in one of the testing beds of like either the ORAN or 5G advanced, where we can find such information? Is it like readily available on Git, where we can get it?
As I said, there are various initiatives. For example, Run Alliance is now promoting these OTIC initiatives where we are setting up different type of laboratories. And there are laboratories like at the Deutsche Telekom where they are successfully testing the front hall. And then we are having also those kind of capabilities in Japan where Symphony and the Rakuten Mobile are involved. So that could be one initiative that we could discuss with the leadership team or the Oran Alliance. We could have a dedicated OTIC to take a look at this OTIC would enable or bring eBPF as one of the fundamental enabling technologies to achieve for the radio access network advanced observability, security tooling, and networking. That could be done there. I also had discussions with some friends to have a work group within the ETSI multi-access edge computing initiative. That would also make sense. Like we could still look into the edge platform and say, okay, since there resides most of the application that demands for low latency and speed, and we could think of employing eBPF on the platform. Overall, I think we will need to bring this dialogue within the 3GPP work groups, thinking of study items for 6G. But I think this technology is mature now. We could have already on networks today, and we could find a way to agree, for instance, that we should make use of eBPF for allowing operator to instrument a Linux kernel based on their use cases instead of making use of this kind of functionality into the user space, which are vendor dependent. So I think that's a big limit. So what a vendor do now, what vendors do now is they tend to say, okay, look, you don't need a network interface probes. Come to me, buy my workloads because I'm already instrumenting my applications and then using you probes. I'm instructed, okay. And then what they do, they encrypt your traffic when I don't need that, right? I don't need you to encrypt that traffic. I do my encryption is I want to encrypt. So that's the point. And you allow me to instrument as I'm pleased the Linux kernel so that basically I can tap below at the exit entry point of the pod or container that is basically independent of the application. This kind of discussion we should have, I think, and that would
Yeah,
enable plenty of innovation and flexibility.
true. I also see in my experience, every time we talk about innovation, there is always a push from the vendors. So my friends, sitting in Nokia, Ericsson, Huawei, this is about time that we have to start exploring innovative use cases. And as a standard organization as well, we should have dedicated, working group. We should have some sort of coordination with different other industry groups. For example, if there is a study going on 3GPP, it should be pushed towards ORAN Alliance as well, and this and vice versa. Because it needs an ecosystem to actually thrive and to be involved. So yeah,
Yeah,
I totally agree with you.
the dialogue would be Taha. The dialogue, in my view, would be like to say, okay, let's discuss how to make this function cloud native, which means cloud native means that they have ability to run on cloud, which is a platform which I am building to not only host network functions to provide connectivity, but I could also offer my AI platform as a service, or I can have my RCS services, VoLTE, or anything, or voice over new radio, anything, right? So that's the point. So we should make and design the network function microservices cloud native so that they work on my platform, which also may demand for the usage of eBPF. Easy. Then
Yeah, yeah,
then it's an operator, so it's the host that has to decide whether you certain things you encrypt or not. After
yeah,
all, they are responsible for the security of the network infrastructure and the cloud infrastructure, not the vendor. Okay, so the
yeah,
vendor may put this as an enabler and don't block the adoption
yeah, yeah, yeah.
and
One of
usage of
the
these
yeah.
technologies.
Yeah, one of the push that is happening in the US market is to have a zero trust security framework, both from the 3GPP side as well as from the ORAN line side. 3GPP is now pushing the release 19 like paper into like standards work into the release 20 like for 6G. And with this eBPF, you can control the policies, everything, since the information you'll be getting a lot of information from your kernel stack, and this is where everything runs. So with that, you can also mature your zero trust security framework for the telco workloads as well. So yeah, that's like quite an interesting point.
Yeah,
Uh,
absolutely. You would set the requirements, then you would leave to the operator, not to the vendor, to the operator. So the host or the platform, the way of achieving this security, and eBPF is definitely
yeah, yeah,
one of the fundamental enabling technologies to do that. I presented a few
true.
slides also how Cilium and Isovalent has achieved that by
Yeah,
moving TLS from the upper layers, the service mesh. That's particularly what the vendor are doing
yeah,
down to
yeah.
the kernel space.
Okay, okay. Thank you very much, Mr. David. It's been absolutely a pleasure, having you with us. I really enjoyed your presentation. It was very practical, and I'm sure everybody who is watching this show have been delighted to have your views and insights. I really liked how you showed us a demo. By like first explaining this complex technology in like easy to understand like language. Hey, this is one, this is two. Just do this, and you'll be done. And then showing at the end how you can apply all this. So I mean, this has been absolutely a pleasure for me, and thank you very much for like accepting my invite. I know like you have been very busy. You have been the most invited speakers, and I have read your 6G. The time when you have published your paper. It's been I've been following you ever since then, and
By the
will
way, that
continue
paper
to
is still
follow you.
valid. I wrote that in 20, so it's 4 years ago. It's still valid. I got it right also on LLM, and yeah, I didn't
Yeah.
talk about eBPF because this is things that became on the table. They came hot, say only recently, but yeah.
Yeah, yeah, yeah. So we'll be ending up our discussion, folks. Thank you everyone who have signed in. I'm sorry I did not get the chance to take all the questions. You can follow me like the My Security Pulse channel as well as Mr. David. He's been like reachable on LinkedIn, as well as he's been very active on different conferences. So try to follow up with him as well. Uh, 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 like so, Dr. David, do you want to leave your last thoughts?
Yeah, perhaps I could show you my vision on future security and current and future if you want. I have made one
Uh,
slide for this, or do you have time for this or not?
I think we may have to do it in a separate session.
Okay, we could
Yeah.
organize a discussion where I could present what I think are the security area which I think will be really on focus and yeah, why not?
Sure, we'll be love to have you. We'll keep it in a separate, because I know you'll be having a lot of other like follow up questions, and we can certainly cover in a different webinar. So yeah, I mean, thank you very much, and wish you all the best in your future endeavors, as well as your work in Rakuten has been very much appreciated, and you are doing wonderful job to the whole community in general.
Thank you so much, and thank you again for having me. I look forward to the next discussions where we can go through beyond eBPF, what other areas and domain should be covered,
Sure.
investigated. Yeah.
Sure. Sure. Thank you very much, everyone. Hope you have a wonderful time. Keep following Security Pulse. We'll be keep giving you some insightful content. All the best. Goodbye.